Hello everyone, my name is Aniket Digra and I'm currently completing my BTech in Computer Science Engineering from BIT Pune, India. So the project I'm developing during the Gemini SOC 2026 is called an AI World Intelligence Map, which basically visualizes all the global events that are happening in real time around the globe on the LG rig, and it also uses a Flutter application to control the rig and also AI narrated voice explanations. So the idea behind this project is simple. Right now, if you want to collect or view any news event happening around the globe, you have to scroll through the news or look at flat 2D maps. So this is where the Liquid Galaxy comes in, which uses its multi-screen setup to project the whole world. Right now, the app pulls the data from three data sources, which are USGS for earthquakes, NASA for the wildfires and storms, and WHO for diseases. And further, I'll be adding GDELT for global conflicts. I'm using the Flutter block architecture with Flutter maps and Hive as the local storage. So let's get on the machine and I'll explain you some of the code and also the demo of the application. So yes, here's the project structure. I've followed a clean MVVM, which stands for Model View Model Architecture throughout. The data layer has three services: USGS, NASA, and the WHO, each passing their respective APIs into a common global event model. The event repository fetches all three in parallel using future.wait with independent failure handling. So if one API is down, the others still load. The block layer manages all state, filtering, source toggling, event selection. The presentation layer is completely decoupled from the data logic. Utility logic like top regions computation is extracted into separate helper files to keep the codebase clean and maintainable. Now let me show you the app in action. So this is the home screen. It shows a live overview, total active events, earthquake count, disaster count, and disease alerts, all updating in real time from the APIs. Below that is the severity breakdown, showing how many events are critical, high, medium, and low severity right now. And here are the top active regions derived from the live event data, showing which locations have the most active events at this moment. Then we have the map screen. So this is the Flutter map with OpenStreetMap dark tiles. Each marker is color coded by category: red for earthquakes, blue for floods and storms, orange for wildfires, and purple for disease outbreaks. Notice the cluster badges. So I've used clustering because there were many events in the same region. So in dense earthquake zones like California, marker groups together, showing the count. The badges scale in size and color based on the severity. Green for small clusters up to red for large ones. So based on the events that are in the cluster, the severity of that cluster is defined. So then we have the event detail page. So if I tap on an event, the event details card pops up, and it shows the category with its color, severity badge, source chip, description, and the location. Now I'll tap on the fly to LG button and see what happens. So the LG rig flies to the event location on the master screen, and on the right slave screen an overlay appears with the full event details, category, header image, situational insight, coordinates, and source. This information that goes beyond what the app shows. It's designed for someone standing in front of the rig to read at a glance. Now we have the settings screen. So the settings screen handles the LG connection, and the connect button shows a loading state, switches it to the disconnect button on success, and shows an error. It also shows an error with a timeout if the rig is unreachable. Data sources can be toggled independently. The API section shows live health of the each source, which sources are currently successfully fetching the data and which are not. And the LG quick commands let you clear KML, refresh, reboot, or shut down. I'll quickly show the clear KML command. So as you can see, all the KMLs are now cleared from the Google Earth. Now, coming up in the next phases, my focus will be on the integration of AI for natural language queries and regional event summaries. And I'll also implement Flutter TTS for voice briefings for the daily global pulse, and also brush up the UI UX of the app. I want to thank my mentor Siddharth and Andrew sir and all the rest mentors from the Liquid Galaxy team for their guidance on this project. Thank you so much.
My name is Ankit Yadav, and my project is Climate Change Storyteller that basically tells the user how the climate is changing with the time. So let's see the app. How the app looks like. So these are when the user opens the app, the first four screens are like the first screen which comes to the user is the onboarding screen with the next and back layout you can see, which tells about the app. The first screen is basically this map screen. I've tried with the uh, Google Map API also, but that has some problem. So I am doing this with the Flutter map right now, where we have added the specific locations as per the uh, of the climate we have to see. Next screen is timeline. Basically, the user can slide and check as we slide. So the this part, this data below the climate data is coming by the API keys like NOAA, Gibbs, and IPCC AR6 report, which is for the forward projections like future perspection. These all are like working, but the KML visualization part is yet to the fly to command is working right now to these location. The narration part is also done. If I show you, so this
Today the
below,
Arctic is warming 4 times faster than the global average.
so the below part is the generated code with the Gemini API key, and these voice style are added basically by the fluctuations in the pitches, like the pitch difference can create these specific voices. This is data screen which shows the data just. This is the story screen where the five chapters are added by now. Uh, these are for the ice and the Amazon basically and the sea level only right now. These are also working. The content is added, but we have
The
to work
Arctic
on
in
it also.
1900 was a vast.
We have to work on the like the duration. The duration is less by now, so we have to change in prompt of duration which we are giving to the Gemini. This screen is basically forest. This is the forest specific screen where the user can see how the forest is changing with the time in the different locations like Amazon basin, Congo, Himalaya, and these years. There are short duration of uh, distance like where these are yet to we have to I have to work on them by now. So we will be working on the KML difference also, like that will tell how it was in 2000 and how it is in right now or in 2000. On the settings screen, we are done with the language where these all language are available by now. So if we click the apps, these all like you can see languages changing. KML caches basically if we have to run the KMS offline so we can download them in a cache. LG diagnosis I will show you that this is working. This is about screen styles. So now you can see that the app is connected with the LG. So let me show you this LG diagnosis. So this button basically tells what are the configuration of the OS, and as you can see diagnostic report basically it tells where the KML and which KMLs are permission and which are right now and how where they are located, and it tells how the SSH connection is active or deactivated. So this all is a diagnostic basically. Okay, so now if I try to show you, so you see that the fly to commands are working by right now, but the KML visualization part is yet to be done. So let me show you. So you can see that the LG is responding with the app in flight to commands are working properly, but the uh, KML visualization part is yet to do, and the AI prompt where we have to change that part is left, and the content for the story is yet to be done. So thank you.
Hello Liquid Galaxy, this is Anirudh Pratap Singh Yadav, and this video is a part of midterm evaluation for Gemini SOC. And since you know, I have been building Arkanoid multiplayer Arkanoid game, which is powered by Gemini for AI. And if I talk about this project was actually made a lot. Like this game was actually made a lot of years back, but it was only a single player game or maybe not without AI features. But this is for us this organization, as we can just play it with the 3 players or 5 players maximum, and in 3 screens or 5 screens, where one screen will be the master and 2 screens or the 4 screens respectively will be the slaves. So it would be a very good experience to play with friends or your teammates, anything. And it can be a multiplayer where you have to break the brick. And I have added some Flutter TTS where you get the sounds. And suppose it is an event based commentary, so you get to hear some commentary based on your whatever your leaderboard score is, and whatever your high score is, and whatever your event is happening. So let me just first connect it, and since I'm using my friend's phone, see, it shows my name. I have joined. I can join it from the session code or the QR. So I've already figured it out. I'll just write one more my name, and see, so I have joined the game, right? So it is waiting for one more player. Since I don't have one more phone, it cannot happen, because a minimum requirement is for 3 multiplayers. But as I received the comments from my mentor, it says that we can also has two players. So I will just fix it one more time, and then we can choose from 2 players to 5 players. And it is basically the app is basically the controller, wherein your whole Chromium browsers would display the environment where you will play. There will be a ball, and there will be a bubble robot wherein you will see the commentary, and also the leaderboard, and also the Gemini commentary powered by there. And but the Gemini commentary will be here. And I've also added the fallbacks. I have added a splash screen, which was I took only a second to add this, because it is very good, and I have taken help of Gemini for this. I have also taken help of anti-gravity. Kudos to anti-gravity, and thank you Gemini team for helping me out, because anti-gravity has helped me for physics of this game. This is my first experience building game, and physics was the subject I never thought I would actually do after my school life. But this game has fascinated, and has allowed me to go to the physics and also learn it for the game development. And there's coming back to screens, so I have a connecting screen, controller screen, the joint choice screen where you see the bubbles, and the lobby screen. Anyhow, this for now, whatever the future thing is left is the proper connection, and changing from 2 players to 3 players to minimum 2 players requirement, enhancing UI more better, and enhancing more AI features. I have been asking my mentors, Siddharth sir also, about AI features, and I think that will be a very good experience. And since we have more than 1 month left, I think we will be able to do much more kind of things in this. And for now, I have more queries regarding this. So it's been a good journey, and also I have been taken inspiration from Karthik, who's building RPG game. And for now, this game is being good, and it also shows the time. It also shows the time wherein you can see the time zone, and it can be time based or it can be infinite, but it has to stop somewhere. So I have put it a time base where you can select time from 3 minutes to maximum time. And this journey so far has been good. And thank you to the mentors. Thank you. And this is Anil signing off.
Hello everyone, my name is Dipen Nandwani, and I am developing Air Mashup Intelligence, an AI-powered airspace visualization application for the Liquid Galaxy system. So far I have successfully integrated the OpenSky Network API to fetch live aircraft data and visualize aircrafts over India and Spain on the Liquid Galaxy rig. I have also implemented aircraft connection visualization to show relationships between nearby aircrafts along with Flutter TTS to provide an interactive and accessible user experience. Moving forward, I plan to integrate a machine learning model like XGBoost to predict aviation data such as future aircraft positions and potential congestion or risk regions. I also plan to integrate a Gemma model to generate AI-powered storytelling, making the visualization more immersive and easier for users to understand. Thank you. This is the demo of my application. As you can see, I've connected my application to the Liquid Galaxy rig with the help of SSH connections. Now I will click on the send logo button, which will send the Liquid Galaxy logo on the leftmost screen, that is LG3. Now as I move to the home screen, the first button is visualize aircrafts in India. As I click on that button, you can see that the aircrafts will now be visible in India. Yep. As you can see, the aircrafts are clearly visible in India, and also if I click on one of these aircrafts, it will start showing me details about that aircraft. Now I can also clear the visualization. That will clear the visualization of aircrafts in India. Now next, if I click on the visualize aircrafts in Spain, the camera will pan to Spain, and it will start showing me the aircrafts in Spain along with its information. I can also clear the visualization through this button. Now when I move to the flight routes screen, similarly you can see visualize Indian aircraft connections. The button is there, and as I click on that button, the camera will now pan to India, and it will not now start showing the connections on the Indian aircrafts. As you can see, the Google Earth pans to India, and now it shows the aircraft with connections. The aircrafts which are close to each other have a particular connection between them. As you can see, these are connected by these yellow lines. I can clear the aircraft connections with the help of this button. Now after this, when I click on the visualize Spain aircraft connections, now the camera will pan to Spain, and now it will start showing us connections between aircrafts in Spain. So as you can see, aircraft connections are visible. Also, I can disconnect from the LG rig with the help of this button. As you can see, we have disconnected from the LG rig. This is the code for the application. As you can see, this is main.dart, which is the main entry point of the application that initializes the app and defines navigation between the screens. Then next we have models. So we have flight.dart, which defines the flight model that stores aircraft information like positions, altitude, heading, speed, and call sign. In the next we have services. So in the services file, as you can see, we have authorization underscore service dot dart, which specifically authenticates with the OpenSky API and retrieves an access token. The next we have connections.dart, which manages SSH communication with the Liquid Galaxy system. In constants.dart, we have reusable constants and application configuration values. For the globals.dart, we have the global variables such as the SSH client and other connection status. For the KML underscore service.dart, we generate KML files to visualize aircrafts as icons in the Google Earth. In the next, we have OpenSky underscore service.dart, which fetches live aircraft data from the OpenSky network for a selected region. The next we have is route underscore service.dart, which shows the KML flight connection lines between the aircraft positions. In the next we have TTS underscore service.dart, which shows us the text to speech for Flutter application. Next we have the screens. This is the flight routes screen, which visualizes flight connection routes for India and Spain using generated KMLs. In the next home screen, we are having live Google Map and visualization of aircrafts over India and Spain in the Liquid Galaxy rig. In the settings screen, we have the settings which handle Liquid Galaxy connection status and also provide system control actions for testing the Liquid Galaxy rig connection.
So hello everyone and hello Liquid Galaxy team. My name is Amit Verma and today I am presenting my Gemini Summer of Code project, AI powered travel itinerary visualization system. The objective of this project is to be help user can create personalization itinerary based on their preference, such using a generative AI. So user basically simply provide details such as their destination, trip duration and budget, travel budget and person, so and interested. So and the application generated as well structure itinerary tolerate to their needs. To make the experience more attractive and interactive, the application integrated Gemini for the itinerary generation, and second one is GeoAPI for our location and map services, so, and the Liquid Galaxy for immersive visualization. So this allows user not can only generate a travel plan but also explore their itinerary visually, make it easy to understand route and destination before the actual trip. So to build a scalable and maintainable application, I have also been organizing the project using a feature based clean architecture, making it easier to extend with the new features in the future. With the overall, let's move on the live demonstration and see how application work in practice. So let's go.
Now let me demonstrate how the application really work. So first of all, as you can see my screen, there are my three machines, and first one is LG1 and second 13 is our slaves LG2 and LG3, and this is my desktop of my application and interface, also call it interface of my application. And as you can see my virtual box, all three machines are running, LG1, LG2 and LG3. So let's go to the demonstrate my application. And first of all, user can enter their travel preference such as a destination, trip duration, budget and other trip details. I set the Mumbai location and set the travel date is to be 50 to 80 and 4 days, and set how many member for one, and set budget is 10,000 INR and generate itinerary. As you can see, the Gemini generated the itinerary and day wise, day 1, day 2 and day 3, day 4. After submitting all requests, so the application send input to the Gemini API, so which generated personalization travel itinerary. As you can see, the many places which are provided view map and view in Liquid Galaxy. So user can also visualization on map. So as you can see, the location of this place are there. So once the response is received, it is passed into the application itinerary model, making the data structure and easy to display instead of the showing of raw AI text. And now let's go to the visualization on Liquid Galaxy. As you can see, I will fill up IP address, username, password and too many things. And next, the application generated visualization on the Liquid Galaxy, so user can also visualize on their Liquid Galaxy machine. So this is a place. So the generated itinerary is presented into the user inside the application, where they can receive each destination and its details. Next, as basically that is my demo part. So thank you for watching.
Conclude the live demonstration of my project. So far, I have successfully completed the core functionality, include the AI powered itinerary generating and map visualization and Liquid Galaxy integration, providing the user with the end-to-end travel planning experience. Moving forward, my focus will be to enhance the project with the more intelligent and interactive features. And one of the key improvement, I plan to add AI travel assistant bot, allowing the user to refine their itinerary through a natural conversation, asking travel related question and receiving the personalization recommendation in the real time. So I also plan to continue improving the overall user experience, optimize the application performance and the further refine the project architecture to make the system more scalable and maintainable. So thank you for time and attention. I would be happy to the answer of any question and receive your feedback. Thank you for watching. Hello everyone and hello Liquid Galaxy Mentor. Today I would like to present the progress of my Gemini Summer of Code project and give a short demo of the application. The goal of my project is built to AI itinerary visualization system planner, where user can enter their itinerary and travel preference and get a personalization itinerary with the suggestion places. Along with the itinerary generation, the project also included map visualization system, and later I plan to extend it with Liquid Galaxy integration. For more immersive experience, since the last evaluation, I made solid progress on the core functionality of this project. One of the main issue early was the Gemini integration was generating inaccurate or irrelevant places suggestion. To improve this, I worked a prompt engineering and refined the response passing logic. After these changes, the itinerary generation has become a much more accurate and suggestion places are now more relevant. I work completed so far I completed the following major parts. First of all is Gemini API integration has been completed successfully, and second one is Gemini are more correctly into a itinerary model. So geo and third one is geo API integration is working, so resolving places coordination. So I plan completed so view on normal map and functionality. So far user can directly visualize the suggestion places on the map. Along this core functionality, I also started on the project architecture refactor based on a mentor feedback. So I received and I began to recognize the code base into a more future based and clear architecture orientation structure by separating into a layer such as data, domain, presentation, and repositories and service and qubit and block and widgets. This refacting is making the project clear and maintaining the early to extend in the next part. Now quickly demonstrate the how application currently work. So let's go.
So this is my current flow of application. First, user can enter their travel preference such as destination, trip duration, and other trip related details required in itinerary generation. I will choose Indore, MP, and set a date, and the number of travel is 1, and set a budget 10,000 INR. Okay. After receiving the all response, I face the Gemini output is converted into itinerary travel itinerary model, so that app can display the trip data in a structured way instead of the showing raw AI text. For each suggestion places is the itinerary, so I use geo API so to solve the location coordinates. That this allow the app to map the places properly and prepare their visualization. So the summary's current flow is basically this is the Krishnapura Chhatra, and I will tap on a view on map, so the app showing the current location, and my pending work is Liquid Galaxy, so that you can also view in Liquid Galaxy. So this means that end-to-end AI itinerary generation flow now working successfully in this application.
Now coming to the next step, the major work that is still pending is Liquid Galaxy integration. The next goal is to be connected the generated itinerary with the Liquid Galaxy system, so the user can visualize the itinerary location which more immersive rather than normal map. So along with that, I also want to complete the remaining architecture refactor and finishing moving the reset of the business logic into the new clear architecture structure, and including the remaining qubit block migration whenever needed. So along inheritance, I am planning is add to be AI chatbot feature to the project. The idea is to be make the app more interactive, so the instant of the generating static itinerary, so the user can chat with the system, refine trip preference, and as follow up the travel question and modify their itinerary conversations. So the next phase I focus will be mainly completing the remaining architecture refactor, finishing the qubit block migration. Third one is implement the Liquid Galaxy integration. So that my current progress of my site. So thank you for watching.
Hello everyone, myself Abhishek Chaudhary, and I'm an intern under Liquid Galaxy for their Gemini Summer of Code program. The project I'm currently working on is called LG Quick Rig. In this project, our main motive is to make widgets to make the access of functionalities easier and make it more quicker for our LG ecosystem. So let's get started by first connecting to our rig, and then we'll go to some widgets and check their functionalities out. Firstly, let's talk about the 4x1 widget. We have the clean KML button, the relaunch button, the reload button, and the shutdown button. I'll show you the functionalities of reload just to showcase how the widget works. As you can see, as I press reload, the LG rig is now reloading. And now that our LG rig has been reloaded, let's first get connected. Now that we are connected, firstly I want to showcase this fly to button. Okay, so here we have this window open where we can add the latitude and the longitude. Let's just do a simple 0 latitude and 0 longitude and fly towards it just to see whether this widget is working or not. As you can see, this functionality is working very well. Next is our overlay button. Overlay button is basically we can add our custom KMLs or testing KMLs for our app. We can choose any red pin, yellow pin, or an image. You can also drop an image inside of here. For now, let's just do a yellow flag and we'll drop it on 0.0 and send it here. As you can see, we are showcasing this flag button. Next, let's just clear this and let's move on to some other buttons. One is this KML test button, which is only for testing whether our KMLs are working or not. As you can see, we are working. Let's just clean this, right? One more thing I want to showcase is the current view button. So if we choose a certain, let's say red pin or yellow pin, and we click on use current view, our pin will get dropped on that latitude and longitude. As you can see, using our current button, the KML drops on that certain location only. Now let's talk about our Linux widget. Unfortunately, our Flutter does not support any Linux version below 20, since our Liquid Galaxy has been working on upgrading, optimizing our LG rig to work under 24.04. This is the version I have chosen to showcase my Linux widgets in. So firstly, we have this application based UI, which is quite similar to our application. So when we connect, our LG widget turns green, and when we disconnect it turns red. And our LG widget has similar functionalities to our application only. For example, we have this KML test, which just checks whether the KMLs are working or not inside our rig. As you can see, it's working. Then we have the clean KML, and then we have the reboot, restart, shutdown KML, and let's just press reboot to check whether it's working or not. And moving forward, I'll be doing AI implementations also on it as discussed with the mentor. So for use case of AI, I'm planning to redesign it as a context-aware LG Copilot, accessible from a floating action button instead of a separate AI screen. The Copilot will understand the current screen and the context, connection status, current actions, etc., and use functions calling to perform existing quick rig actions like flying to a location, dropping pins, or starting an orbit. The goal will be to make existing functionality easier to use rather than adding something like a standalone AI feature.
Hi, Liquid Galaxy team and mentors. I'm Samatna Bharadwaj, and this is my project for Gemini Summer of Code program. So, this is basically an Earth System Explorer immersive visualization of global climatic processes using Liquid Galaxy, which I'm developing as a part of Gemini Summer of Code program. The objective of this project is to provide an interactive way to explore global climatic processes using the Flutter-based mobile application as the controller and the Liquid Galaxy rig to provide the immersive visualization. In this presentation, I'll briefly walk through the project architecture, code I developed, and then demonstrate the implemented features using the virtual Liquid Galaxy. The First, let me begin the code walkthrough. First, starting with the SSH communication layer, this file is basically SSH client.dat, which is basically responsible for establishing and maintaining the SSH connection with the Liquid Galaxy master rig. So, every command that is sent from the mobile application passes through this client. Um, then next is the sh command.dart. Instead of hard coding commands throughout the application, all Liquid Galaxy commands are basically centralized here, which includes the fly to, power off, and then refresh KML orbit, etc. And then the next is look at model. Liquid Galaxy expects the rig expects camera movements in the form of look at objects containing longitude, latitude, heading, altitude, and the range. So rather than generating XML directly inside the UI, I created this reusable model which converts camera parameters into the KML representation required by the Google Earth. So this model is basically used for two features right now, which is fly to and Google Maps synchronization. Now coming to the KML generation part. The KML basically, which you can see here, is the concatenation of polygons using Bezier curve. So each polygon has a separate color, which is defined here in this function, interpolate color, which is as a function of the control point of the Bezier curve. So as the curve increases, the color too changes in a gradient way. So this KML is basically pre-generated and loaded to the Liquid Galaxy rig when the button for the following action is pressed. Now let us see how the KML is visualized and how the app functions. So first, basically, let me start with visualizing Indian monsoon. Now it should go to the Indian subcontinent region and visualize arrows depicting the rain-bearing winds, and then the logos depicting the cloud regions having higher rain, and then the low pressure region. And then we get a summary of the effect generated by Gemini Flash. And I need to implement the reading of this using Flutter TTS, which I'll implement in the upcoming days. And then you can also visualize Kuroshio current. So this flies to the Japan region, and then the arrows depicting Kuroshio current can be seen. Similarly, we saw the visualization of Gulf Stream. So this is the visualization of the Gulf Stream, the arrows depicting the path along which the ocean current goes. And then I also have implemented the map sync. This depicts the region of the Gulf Stream, which is the east coast of US. And then when I press visualize Kuroshio current, the Google Maps should show the region of Japan. So the maps sync to works. And then this is the placeholder for additional visualizations, which I'll be implementing in the upcoming days, which is different wind effects and ocean currents. This is the dataset screen, which is hard coded currently. I need to work on fetching, processing, and cleaning of the data. And then this is the Liquid Galaxy rig control screen. So you basically can shut down clear KML, show logo, orbit, and refresh KML. And this is a settings page where you enter the credentials and connect to the Liquid Galaxy rig. I also have provided a dark mode and colorblind mode for accessibility. So the next phase of development will basically focus on integrating more AI-based features like the chatbot, which is called Climate AI, which have basically only developed the basic screen off. And integrating the scientific climate data sets and creating the additional Earth system visualizations. Thank you to the mentors for providing guidance throughout the program. I hope I'll be able to develop my project successfully. Thank you for watching my presentation.
Hello everyone, my name is Tanishq Sharma and this is my submission for the midterm evaluation of Gemini SOC. My project is Cyber Visualizer and this is my GitHub repository. Now let me show you my code base. This is my code base. To set up and run my project locally, you need to clone that repository and then come to this .env.example and rename it to .env. Then you need to paste your API keys here. After that, you need to go to the strings.xml.example and then paste your Google Maps API key here. And also rename this file to strings.xml. So These API keys can also be changed inside the application, but the Google Map API key needs to be set up before running or building the APK for the application. Next, in the last few months, I mostly worked with the lib folder. So this is how my lib folder looks like right now. I've tried to keep my code modularized so that it is easier to debug later and also easier to add more features. So this is the models folder. It has various different models for different data sources. So for abuse IPDB, we have these parameters. It handles these parameters. Then attack event handles the live attack feed and so on. Next is the pages. So these are the pages that the UI shows. This is for the settings page, the future attack simulation, and the track IP page. Next comes the providers. So this is the attack provider. What it does is it handles the change between UI. So whenever you refresh and get the latest batch of attacks, so this handles that processing. Similarly, the track IP provider also functions in a similar way. So next is the repositories folder. Here we have attack repository and track IP repository. The attack repository handles fetching of new events and then parsing them using the attack event model that we saw before. And similarly, the track IP repository fetches the IP report using the IP address and the IP window that we pass to it. Next is the screens folder. It has the default screen that shows the live attack feed. Next, the services. This is the core of the application. It has different services that talks to different APIs. The abuse IPDB service calls the abuse IPDB APIs to fetch the IP report. Similarly, there's the Gemini analysis helper. This is just a helper function. Then next, the Gemini service.dart that handles sending prompt templates to Gemini and then parsing the results. Next, the Honeylab service.dart that fetches the live attack streams from the Honeylab API. Next, we have LG adapter.dart and LG service.dart. These are the This is how we connect to the Liquid Galaxy rig. Next, the text to speech service.dart that uses Flutter TTS and the track IP LG service.dart that has some helper functions that helps to calculate different camera trajectories and different camera views for the track IP service. So now let's move on to the demo. So this is how my application looks like right now. The Google Maps is currently a work in progress. This is a live attack feed page. So let me quickly update the attack feed. Fetch telemetry. So these are the types of latest attacks that we fetched from the honeypot. So we can see there are about 10 brute force attacks. So let us check these out. Let us visualize all of them on our LG rig. So we can see the screens changing and these are the attacks. We are seeing just two attacks because the source of the attacks is probably the same. So if we click on one of these lines, we'll be able to see multiple attacks from the same place. We can see two detections from here and the rest will be from the other line. So now we can also ask Gemini for more detailed insights about these attacks, analyzing the category brute force. I've also integrated Flutter TTS, so whatever insights Gemini generate, we can also hear them. So these are this is what the Gemini API returned. Once we click on this sound
Executive
icon,
summary. Recent telemetry indicates two distinct types of
I hope
brute
this is
force
visible.
activity.
I hope this is audible.
A significant portion, 8 out of 10 events, involves targeted.
So this is how the live attack feed is working right now. For the connection settings, you can visit this page and input your API keys here and input the LG rig credentials here and connect with the LG rig. So now let me just quickly clear the KML. Next, let me show you IP tracker. So this IP I got from Abuse IPDB. This was listed as one of the recently recognized threat IPs. So this should give us some report of malicious attacks for sure. So we can see the KML lines loading on the LG rig. So we can see that there have been a large number of attacks using this IP address. Let us see one of those attacks. Okay, so here we can see that there was a brute force tried from this region to Canada, and Canada reported it. So similarly, this is the IP tracker card. It summarizes all the information. There are a total of 801 reports in last 5 days. And below we can see the list of all those attacks right here. We can also ask Gemini for the latest insights and use the integrated Flutter TTS service for listening the report. Next comes the attack simulation. Let us try this botnet spam wave. Simulate scenario. Yes, so we can see the attack vectors projected successfully, and these are the attack vectors as we can see. So this actually utilizes the direct KML file generated by Gemini API and displays that directly on the LG rig. That is why these lines are looking flat and not having that parabolic shape. So I'm currently working on that. So this is all for my application right now. So this is the list of future implementations that I would like to add to my application. I would like to add 3D tools for IP tracker, live feed, and future tax simulations with the camera moving by itself as it's a tool, and also AI voiceover. Then I would like to add important historical events related to cyber attacks. I found an interesting data set regarding these historical events, so I would like to integrate that into my application. Then QR-based connections are pending right now. I'm also working on improving the attack simulator to make the KML lines match the theme of the application. As we saw in the demo, they were flat right now. Also improving the system prompt to get more effective and more better KML. Next is fixing the Google Maps on Android emulator. So this is all for my video. Thank you.
Hello, my name is Trang. I'm originally from Vietnam and currently living in Barcelona, Spain, and I am a student from the FP DAM in university and also a Migra Code student. So today I'm going to show you the demo of my applications for Gemini SOC this year 2026. So this is my applications. This is the splash screen. I have two of them. This is the first one and the next one. And after that, we're gonna have, this is the home screen and the status is not connected. So we can come here and connecting to the screen. So this is, the number is 29, the port here users. And this is our password is LKey Galaxy. And the number screen is 5. So let's connect to Liquid Galaxy. So you can see here on the screen, right now I am having this logo, but actually it's not on the right place, but I'm gonna try to modify this later and move it to the to the leftmost screens. And here, after you connected, we can see the status here of the connectivity, and this is the tool screen. So as you can see here, if I click on clean logo, so the logo on the screen is clear. And also I have the dark mode here. So, and also this is the map screen. That the part of it I already implemented, but I still need to modify and update it. And also I'm gonna show you the code base in my computer. Yes.
Hello, I'm Chang Do, and now I'm gonna continue showing you the code base from my side. So as you can see here, this is the code base with different screens here. First of all, I have one splash screen. This is the number one screen, so that it displays the logos, different logos, and then after 5 seconds it's gonna move to the slash screen number 2, and in here we have the hook questions and also like a loading spinner. And afterwards it's gonna move to the home screen. This is the first screen, and in here we have the connectivity buttons and also shown the status of connectivity. And once we click on the connect buttons, we're gonna move to the settings screens, and in here the SSH connection is gonna be authenticated, and if we connected successfully, it's gonna return a status. And afterward, we have the tool screens, so that we have different commands to control the LG rig. For example, like relaunch, reboot, clear KMLs, or clear the logos. And afterward, this is the map screen. I'm actively working on it. This one is not finished yet, but I'm actively working on it. And we also have like different services here, and later I'm gonna move all services into one folder to have the clear architecture. And also the data now is a hard-coded list, but ideally it's gonna be fetching from the API, and I'm gonna do it in the next steps, because now I have it here, so it's easier to test everything. And also this is the nav button bar, so that I have it here and share it between the different screens, so we don't have to repeat ourselves. And later in the next steps, I'm gonna finish with the map screens, integrating with the Google Maps, and then send the KMLs to the multi screens, and also start building the chat applications, the chat screen actually. So far this is what I have done, and the next steps for my projects. And thank you so much for listening, and see you soon. Bye bye. Thank you. Hãy đặt một cây ở Hồ Hoàn Kiếm, Hà Nội, Việt Nam.
Design, Minda Dua Liquid Galaxy Toy Ho Hon Kim, Hanoi, Vietnam. Kong Koi Dong Lai Mai.
Hello, I'm Chang, and I'm the GSOC, Gemini SOC intern at Liquid Galaxy, and currently I'm at the lab right now. So this is my experience in the 2 days for the short visit at the lab, and for the 3 days actually. It was really amazing, because I had the experience to work with the agent, and to know how it works with the LMM, and also like use the agent to connect with the Liquid Galaxy. And I think this is a very interesting and actually really amazing opportunity for me. And I want to say thanks to everybody at the lab, to Andrew, to Jasmina, Joseph, Jan, and Fabrizio, and also Orion, because everybody has helped me a lot during this visit and shown me a lot to like everything, the hardware and also the software and also the robotic. And I'm really excited, and I hope that I really appreciate this opportunity and hope to be here very soon again. So thank you very much.
Hi everyone, I am Siddharth Mudgil, GSOC mentor at Liquid Galaxy, and this year I am also coordinating Gemini Summer of Code program with the help of admin Andrew and other mentors. And so far I really had very wonderful and enjoyable journey with the Gemini Summer of Code program. The one thing I really enjoyed about this program and I really appreciate is like how all contributors are very collaborative, and how they are keeping Discord channel created for this program very active. And even during the doubt sessions, like all contributors were very active in participating and helping other. Like many contributors suggested new feature ideas to other fellow contributors, or suggesting new approaches how to solve a bug. And that was the main goal behind this program, Gemini Summer of Code, and I think we already achieved that goal. And so far it's very good progress only.
In the end, I want to say that all the best to all contributors who are participating in Gemini Summer of Code program, and thank to all mentors and admin and rules. Thanks. Bye.